Hello everyone, my name is Mathieu Meur and I'm the director of DP Facade. I'm a facade consultant by training. I've been doing this for over 20 years. I've worked on projects, probably around 500 projects on 6 continents. This is what really makes life as a facade consultant very, very interesting and very challenging at the same time, working across different geographies, different cultures. Working as a facade consultant can prove slightly tricky at times. We have to be a bit of a schizophrenic or slightly schizophrenic at times. Working with architects, we need to think like an architect. We think of the aesthetics of the building. We need to think how beautiful it's going to be. And we need to make or bring to life, rather, the vision of the architect and the developer. We also need to think as an engineer because it needs to hold itself up, it needs to be structurally sound, it needs to be thermally efficient. There's a whole bunch of engineering considerations that go into creating the perfect facade. We also then need to think like the fabricator, the person who's actually going to implement this. It needs to be something that can be fabricated easily, that can be installed easily, that can be transported. No, you really need to think or wear different hats and think like a bunch of different people. This is why the teams of facade consultants that work with me come from different backgrounds, they come from different training. Some are architects, some are engineers, some are specialists in construction. There's really different profiles that need to come together to make it really happen. So far, over the past 20 odd years, I've worked on buildings that were low-rise but highly complicated mega projects like the Dubai Mall or Resorts World at Sentosa and Universal Studios. Low-rise doesn't mean easy. It's generally actually more complicated because you work with multiple systems, multiple materials, from glass to aluminum to steel, which are very classic facade materials. But then you also throw in stone, GRC, GRP, ceramics, and really a plethora of other materials and other systems that complicate matters beyond recognition. Working on high-rise, the challenges can be quite different because the facade is more repetitive. You repeat it on multiple floors, but it doesn't mean that it's easy either. Other considerations come into play, like building movement, tolerances over the super high-rise buildings can be quite challenging to take into account in our designs. Different projects, different locations, different considerations come into play, whether it's seismic activity, whether it's snow loading in temperate countries, whether it's extreme heats. This is really one aspect I wanted to touch on briefly now, which is what's happening with climate change. With climate change, what we're having now is more extreme weather, greater winds, greater temperature fluctuations, a whole bunch of additional considerations that make designing facades much more complicated and that require much greater care from the facade consultant who's handling the facade. On top of that, to make matters worse in a way, or maybe to make matters more interesting, that's how I'd like to think about it, architects are making or designing facades that are increasingly complex. It's almost like a competition, who's going to get the ideas that outweigh or outdo the predecessor, so to speak. And we get complex geometries, we get various aspects in the design of facades that really challenge us to bring our best when we work on this project. To do this, what we do is we've had to develop or acquire a bunch of new tools that we did not traditionally use. When I started as a young engineer, a young facade engineer, I used to do everything by hand, whether it's the sketches, whether it's the calculations, whether it's everything was done by hand. And today we are using technologies such as BIM, such as parametric design, using dedicated engineering software. We make use of 3D rapid prototyping to test ideas, to see, does it even make sense? Is it buildable? We've even developed tools that are not on the market, so something we call IVMU, which is an interactive visual mock-up, which allows the designers, so the engineers, the architects, the owners, the building developers, to use virtual reality goggles to visualize in real time what their buildings is going to look like, what their facades are going to look like, and to make changes in real time. And this is really a fantastic tool that we've developed over the past couple of years, and that really changes our approach to designing facades on these, especially on these complicated buildings with multiple materials, complex geometries. But ultimately, I'd like to bring it back down to the human level. Tools are tools, and it's all down to those that use it. And this is really where experience, dedication really make a difference in the design of facades and a successful outcome to projects. When it comes to sustainability, one of the key challenges that we are faced as building designers is that of reducing the carbon footprints of buildings that we design. It is notorious that buildings and construction in general contribute to a very large proportion of the overall carbon footprint in the world. There are several levels that as designers we can work on to have a positive impact on this. The first one is during the design phase itself, because a lot of the materials that we use in construction, be it concrete, be it aluminum, be it glass, a whole lot of these materials have a very strong impact on the carbon footprint of the building. They require a whole lot of energy in particular to fabricate these elements. How we can impact that, there are some very simple measures that you can do. One is to adopt or use as much recycled content in the building facades as possible. And as strange as it may seem to the layman, actually it is something that is increasingly happening and without any deleterious effect on the facade itself. Aluminum in particular, when it is recycled, it is infinitely recycled. It's a beautiful material from that point of view. The amount of energy required to create aluminum elements from recycled aluminum versus raw materials, it's reduced by 95%. So it's a really massive impact that we can have. The same goes with glass, for instance. By recycling glass, we can achieve a positive impact by reducing the fusion temperature, the melting temperature of glass, which in turn reduces the amount of energy required to create new raw glass, to create new facades again. And the same can be done with other materials as well. Steel in particular is also very easily recyclable. Other than that, we have new old materials that go into facades. For instance, timber. Timber has been used in construction for, centuries or millennia, in fact. It is something that sort of disappeared in the modern age of facade construction, but is making a very strong comeback. While it has very good advantages, it's a carbon sink in particular, so it absorbs the carbon and stores it inside itself. It has certain disadvantages at the same time, and it can be then combined with minimal amount of aluminum, for instance, to create modern facade with a very traditional look. And on top of that, wood is also excellent in terms of thermal insulations. Timber, I feel, is an interesting product that we are more commonly looking into using, and it is also obviously a renewable resource. The second part is obviously in the operation of the building, so looking at thermal performance of the facade and making sure that the energy consumption of the building is reduced as much as possible by making, in particular, the facade as efficient as we can when we design it. The third aspect is essentially the end-of-life performance of the facade. How easily is it recyclable? How can we either reuse or recycle the elements of the facade to either create a new facade or to turn it into something else. These are three of the simple ways that we can reduce the carbon footprints of the buildings that we're designing today. With this, I'd like to thank you very much, and I'll hand you over to Per Olsen for the next segment. Thank you very much.